Okay, this is lesson 4.6 out of the Introduction to Algebra book. 4.6 is on page 92 in Mrs. Walker's class. Lesson 4.6 is titled Writing Function Rules. All right, and our warm-up on this lesson is to complete the following input, output tables. This is what we learned how to do in lesson 4.5. All right, so let's see, 1, 2, 3, 4. I need 6 lines here. 1, 2, 3, 4, 6. And we're going to have 2 of them. And title line, X column, Y column, and the function rule for the first one is y equals 6x, and the function rule for the second one is y equals 4x minus 2. All right. So on the first table, our x values are 0, 1, 2, 3, and 4. And on the second one, they are 2, 3, 5, 8, and 9. Okay, so work those out. Plug in your x values for y and see what you get for all your y values. I guess I should do those too, huh? Okay, that's your warm-up. So let's get on with our I can statement. All right, our I can statement, what we will be learning in this lesson is I can write function rules for tables or graphs. I can write function rules for tables or graphs. All right. Okay, so dark green pencil all the way across. This is a new concept. You've seen the function rules, but before you haven't known what the different parts of the function rule, the equation, represents. And that's what we're getting into today. So it's a lot. I'm just going to tell you, it's 2 pages and a lot of writing because there's a lot of new stuff here. But there's no way around it. This is a real foundational concept that you've got to get as it sets up what you need to know for several years of your math. And it's very true. All right, so I'm going to put a big red star right out here. And with my purple pencil, I'm going to write big purple or dark blue, I don't know. Function rule. What is a function rule? I'm going to take my pink highlighter and I'm going to highlight this. I really want it to stand out when you're flipping through your notes book. Okay, the function rule. All right, well, the function rule starts with y equals, and there's a number after y, and that number is known as the start value. Okay. Then after that, there will either be an addition or a subtraction sign, so plus or minus. Okay. And then there will be another number, and we call that the rate of change. And we abbreviate that ROC, rock. so the rate of change. And then the function rule ends, whatever this number is right here, it ends with x. So you have a y and an x variable in a function rule. All right. Now this isn't probably making a whole lot of sense right now. Don't worry. We're going to talk about each one of these parts and do examples of how it all works. All right. So we're first going to start. We're first going to talk about the start value. All right. So let's see. Am I in frame? Let's move this up. Here we go. All right. So start value. What is a start value? Well, you've seen it, you just didn't know that's what we call it, all right? So think about an input-output table, like what you did in the warm-up, okay? And here's what I want you to write. Where x is 0, y is the start value. Oops, I didn't need a period there. Y is the start value, and we just abbreviate that as V. All right. So I'm going to use my blue highlighter and mark where x is 0, y is the start value. So I'm talking about ordered pairs here, guys. So up here in this warm-up table, for example, x is 0 here. So whatever y turned out to be when you applied it into this function rule, that number there is your start value. All right? And yeah, and so what's a start value? What does that mean? Don't worry yet, we'll get there, okay? I just want you to kind of repeat this in your head right now. Where x is 0, y is the start value. Where x is 0, y is the start value. Okay, so what's this rock? What's this rate of change? So ROC, what is it? Okay, ROC, it stands for rate of change. And it's the what you see when you're looking down the y values. Okay, so as again, I'm going to use this warm-up table. When you completed this, you got a y value in each one of these, and if I were to look at them going down, these numbers are either increasing or decreasing. And by how much? Okay, because they will be increasing and decreasing when these values are 0, 1, 2, 3, 4. They'll be increasing or decreasing by a specific amount. So they'll either be going up by 3 every time, for example, or down by 2 every time, for example, and that's your rate of change. Right? So you'll get to see examples of that right now. Just take the notes and bear with me. All right? So now, going to show you what these look like in a table, your start value and your rate of change in a very simple table. And I'm going to write, let's see, 1, 2, 3, 4, 5, 6, 6 lines. All right. And right about in the middle. 1, 2, 3, 4, 5, 6. Okay, so we're going to keep it very simple here. With an x and y, x and y. Okay, now my x values in this table are 0, 1, 2, 3, and 4. All right, now my y values in this table are 18, 14, 10, 6, and 2. Okay, now how do we find our start value? Remember that when x is 0, y is the start value. So I'm going to write that over here. Where x is 0, and that's happening right there, y is the start value. So what's our start value? 18. Right? Because x is 0, y is the start value, 18. All right, so now let's talk about on this side the rate of change. First thing you're going to ask yourself is, are the numbers increasing or decreasing. Okay, and then the next thing you're going to ask yourself is, by how much? Okay, so these numbers are decreasing. So I know it's going to be a negative number, my rate of change. And 18 to 14, it's decreased by 4. 14 to 10, it's decreased by 4. 10 to 6, it's decreased by 4. 6 to 2, it's decreased by 4. So that tells me my rate of change, my rock, equals -4. It's going down by 4 on the Y column every time. That's my rate of change. Okay, now, all of this plugs into a function rule like this. Let's go back to my function rule that we were talking about right here, okay? So down at the very bottom, I'm going to write function rule. This is what a function rule would look like for this specific table. Okay? Okay, remember that the function rule starts with y equals, and y equals what? First, we have the, I really should have put this in blue. Sorry. First, we have the start value. That's what goes here. And that is 18. We figured that out. Okay. And then it's plus or minus the rate of change. And our rate of change is -4. So it's -4. And what does a function rule always end with? Always ends with x. So for this table, the function rule is y equals 18 minus 4x. Right? Okay, so that's the first page of the notes. Now we're going to get some practice on how this all works for us to be able to graph this function rule. All right? So hang on and we'll start the next page. Okay, so the next page, we've got, I want you to write right at the very top, again, y equals, what do you have here? And then plus and minus. What do you have here? Always ending in x, right? So what you have here is your start value, and what you have here is your rate of change, okay? Write that at the very top, and I'll in my class, I'll require you to write this at the very top of all your worksheets dealing with this until this is just ingrained in your brain. And it will be. You'll be surprised at how quickly it is. I know it seems a little complicated right now, but it all comes together here real soon. All right, so the first thing that we are going to do is find the function, rule for the input, output table. All right, so this is very similar to what I was showing you on the first page of notes, but now we're going to do it in a few less steps, okay? So you can see a little bit more what you'll be expected to do on your worksheet. All right, so I'm going to have a very simple, let's see, 1, 2, 3, 4, 5, very simple table set up right here of 1, 2, 3, 4, 5, and across and down, and split it in half, and we've got x and y. Here's my little input table. All right, and I'm going to have 0, 1, 2, and 3. And my y values are 2, 5, 8, and 11. All right, so the first thing we need to do is identify the start value. Okay, identify the start value. Well, remember, where x is 0, y is the start value. So here is where x is 0, so that means 2 is the start value. So I'm going to circle that right there, and right down here, 2 is my start value. And make a little note here, x is 0, y is start value. Right there. Okay. All right, so the next thing we need to do is to identify the rate of change. So, identify, I really need a new orange pencil, the rate of change, rock. We got to identify rock and what's happening here. Okay, so I can see that the numbers are increasing. By how much? Well, from 2 to 5, that looks like plus 3. From 5 to 8, again, plus 3. From 8 to 11, plus 3. So, plus 3, plus 3, plus 3. Looks to me like my rate of change every time is plus 3. All right, so now I have all the information I need to write the function rule, and I'm going to do that right here. The function rule for this input-output table is y equals, remember what our format is for writing a function rule. So it's y equals the start value, and what was the start value? 2. Y equals 2 plus or minus the rock. Okay, so we know that's plus 3. Our rate of change is plus 3. And students often forget this last part, so I like to say it over and over again. How do we end our function rule? We end our function rule with x every time. Don't leave that off, all right? So for this input-output table, the function rule is y equals 2 plus 3x, okay? All right, so here's the next one we're going to do. So on this one, we are going to find the function rule. Find the function rule for the graph. Now we're moving this to graphing. Find the function rule for the graph. Okay, so we've got, I'm going to do this, let's see, how am I going to do this? And what's your, hold on just a second, I need to remember what your, looks like. Oh, right, okay, so you got to write the ordered pairs. Okay, so here's what you do. Okay, you're going to be given on your worksheet, you're going to be given a simple a quadrant 1 graph. Let's see, what are we doing? All the way to 10. So 1, 2, 3, 4, 5. All right, so 1, 2, 3, 4, 5, and about the same distance this way. All right, and so middle line, middle line, middle line, all the way up here, and try to keep them even as you can from the, oh, that was not as even as it could have been. All right, so we've got, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And hopefully something close to that here, although I don't think I spread these out as well as I could have. 7, 8, 9, yeah. All right, good enough. Okay, with my dark green pencil, I'm going to plot some points here. My first point is going to be right on the y-axis here at 10. All right, my next one is going to be 1 and 8. So 1 and as straight up as I can, all the way to 8. Okay, my next one is going to be at 2 and 6. So 2 as straight as I can, all the way up to 6. And next one is going to be at 3 and 4. So 3 and 4, and then 4 and 2, and then 5 and 0. All right, so my line is a straight line, not bad actually, going down that way. Okay, so there's my graph, and now I've got to figure out what the function rule is for that. All right, so what we do is we make an input-output table from this graph so that we can identify the start value and the rate of change. And I'm going to tell you that soon you'll skip this step, because soon you'll be able to identify the start value and the rate of change just by looking at a graph. But just so that we can see the just so that we can see how it goes from one to the other in the lesson, we'll start with the input-output. All right, so on this one, 1, 2, 3, 4, 5, 6. I need 7 lines, so 1, 2, 3, 4, 5, 6, 7. And I have my table here. And keep it very simple with just an X and a Y. And we start 0, 1, 2, 3, 4, and 5. And our Y values are 10, 8, 6, 4, 2, and 0. And some of you might already be seeing the correlation happening here. I hope so. All right, so the first thing I have to do is find the start value. Well, where X is 0, Y is the start value, correct? And then I have to identify what's the rate of change. All right, so it looks like they are decreasing, so it's going to be a negative number. And from 10 to 8, it's minus 2. From 8 to 6, it's minus 2. From 6 to 4, it's minus 2. From 4 to 2, it's minus 2. And from 2 to 0, it's minus 2. So every time it's going down by 2. So my start value is 10, and my rate of change is negative 2. So my function rule for this graph, function rule, is going to be, remember the way that we write a function rule, don't forget how that looks, okay? So the function rule for this graph is, where's my pencil? Come back here. Okay, function rule is, so it always starts with y equals, then I need my start value, and we determined start value was 10. Okay, plus or minus rate of change, and it's going to be minus 2. And how do we end a function rule? Always with x. A function rule's got to have an x and a y. All right. Okay, so we did that. Let's make a little note in between to connect these two things that we did. All right. So ordered pairs from graph. All right. So this came from this input-output table. Came from the points on this graph. So to make it, I mean, I know I made it really quick so just so that it would be quick. But when you see this graph all by itself on your worksheet and you're asked to create a function rule, you can set up a very simple input-output table and write, okay, what is the ordered pair for this one? 0 and 10. What is the ordered pair for this one? 1 and 8. Okay, and make all your pairs. And once you've done that, then it's very easy to see what's your start value and what's your rate of change. Now, as I was saying earlier, some of you will be able to, without having to create the input-output table, see that wherever x is 0, put that down, wherever x is 0, y is your start value. So without even making an input-output table, you know your start value is going to be 10, because your start value is always going to be the point that is on the y-axis, because whatever's on the y-axis has an x of 0. So that's how I know 10 is my start value. And then I can start seeing my rate of change without even having to do this, by knowing that every time I go over 1 on x, how did the but how did it change? Did it go up or down? On this one, it's going down, so I know it's going to be negative, and it went down by 2. When I went over to 1, I saw that this point went down 2. It went from 10 to 8. When I went over 1 more, it went down 2. It went from 8 to 6. When I went over 1 more, it went down 2. It went from 6 to 4. So soon you'll be able to recognize that right from this without doing this. But right now we're doing them both just so you can see how they connect, and then you can finally get your function rule. All right? Okay, so then the last thing that we will show in these notes here is, identify the start value, I'm going to abbreviate, and rate of change of the function rule y equals 3 plus 5x. Okay? All right, so again, refer to the top of your page on how we set up a function rule, right? And then you should be able to identify this, all right? So in this particular function rule, what part of it is your start value? It's this right here, correct? So the start value for this one is going to be 3, right? Your rate of change is the number that is with the x. So your rate of change on this one is going to be, and don't forget, it's plus or minus. You have to keep that with it, even if it's positive. Your rate of change is plus 5. All right, now let me show you one other one that might kind of trip you up, and you'll see it on your worksheet. What if the function rule was y equals 7x? That doesn't look like a function rule because it seems like part of it is missing. But it has a y and an x, so I know it is a function rule. And what I have to remember and tell myself, and that's why I'm going to write this right out here, the rate of change is the number that's with the x. Okay, and it doesn't have a negative sign in front of it, so I know the rate of change is positive 7. Okay, but what's the start value? Okay, what's the start value? It's not showing me a start value. So if it doesn't show you a start value, that means it's 0. And there's no reason to put 0 plus 7x, because 0 plus anything doesn't change anything. You know, there's just no reason. So they just kind of kick it out, and that's what your function rule will look like. But students often start thinking, okay, the first number of my function rule is my start value, so 7 must be the start value. No, if it's paired up with the x, that's your rate of change. That means they didn't show you a start value. And if they don't show you a start value, it's 0. All right, so now, how would that look on a graph? Let's look back up here real quick. Can I get them both in? Oh yeah, I can. So this function right here, I still have to plot a start value on the graph. Well, where would it be? If the start value is 0, that means x was 0 and y was 0. Where x is 0, y is the start value. And I'm telling you that y was 0. So that means the start value for this function is 0, 0. Where would we plot that on a graph? That's origin, guys. So 0, 0 is right here, right at the corner. So it does have a start value, and it needs to be plotted. But you have to understand that in the function rule itself, it won't show it if it's 0. All right? Okay, so that's the second page of the notes for lesson, what are we on? Lesson 4.6, right. All right, so let's go ahead and look at some practice problems. Okay, so practice problems for lesson 4.6. The first one has find the function rule for the input-output tables. So that's the top part of the second page that we did. Just work to find your start value and find your rate of change change and complete the function rule written under each one of these. All right, the second part is find the find the function rule for the graph. So create your input-output table over here by using these plotted points, and then identify your start value, your rate of change, and complete the function rule over here. All right. If you can identify your start value and rate of change without making an input-output table, for me, the first time I have students do a worksheet, I have them do the input-output table. Then after that, if I'm confident they can do it without doing the input-output table, then I let them. Your teacher may have different rules, but that's how I do it. All right. Okay, so let's see how we do these. So the first thing I'm going to do is identify my start value. Well, where x is 0, y is the start value. So I'm going to circle that with my pencil here. And then the next thing I'm going to do is figure out how are my numbers changing in my y values. Well, they are decreasing, and it looks like from 16 to 13, that's a -3. From 13 to 10, that's a -3. From 10 to 7, that's a -3. From 7 to 4, that's a -3. So obviously, my rate of change is -3. So that means that I would write my function rule as start value is 16, -3, always end with x. All right, how'd you do? Hope you got that. Okay, next one, where x is 0, y is the start value. Got it. These numbers appear to be increasing as I go down my y values, and they're increasing. 5 to 9 is +4, 9 to 13 is +4, 13 to 17 is +4, 17 to 21 +4. I think I see my rate of change. So my start value is 5 +4, always end with x. Okay, in my last table, where x is 0, y is my start value. How are they changing? Okay, students often all of a sudden decide they don't know what to do here when they see these decimals. Don't let it trip you. You know the 2.5, this is 2.5, okay? You know, don't overthink it, the difference between 2 and 2.5, all right? So they are increasing. 2 to 2.5 means they added 0.5. I don't think I'm going to be able to get that in there. From 2.5 to 3, they added 0.5, 1/2. From 2.5 to 3, they added 0.5, or 5/10. Okay? From 3 to 3.5, they added another half, which I'm representing as a decimal. Okay? So, if it's represented as a decimal in the input-output table, then we should do so also in the function rule. So my start value is 2, where x is 0, 2 is my start value, and I am adding 0.5 every time. That's my rate of change, always end in x. Okay? So that's how we would find the function rule for these tables. Now, how are we going to find the function rule for this graph? Well, I know I first need to find my start value. And where x is 0, which is right here, y is the start value. So on my y-axis somewhere, I got to find a point that is my start value. Well, start value. It looks like it's right here at 0. So what is it? It's 0. I'm going to put it down here right now. We'll fix it. All right? So it appears to me, and this really should, it's going up or down from where it starts from the y-axis, guys. So that's how you know it's not like starting from up here somewhere and going down. It starts on the y-axis and is either going down or up. All right? So my rate of change on this one is for every one I go over, it's going up 1. For every one I go over, it's going up 1. For every one I go over, it's going up 1. So this is a plus 1 always end in X. All right? Well, this looks weird. All right? We discussed on our notes earlier, we don't need this 0 because 0 plus whatever this is isn't going to change whatever this is. So we don't need it. So it really should be written y equals, 1x? When we have a variable and the number in front of it is 1, do we show the 1? No, we don't, because 1 times whatever x is isn't going to change x, because 1 times anything is still itself, right? So we would get rid of this 1 as well. And so the function rule for this line on this graph is y equals x. Okay? Now that looks a lot different than what we're used to seeing with these longer function rules, but what makes it a function rule is that it has a y and it has an x. And when you have a 1 over 1 up, 1 over 1 up, 1 over 1 up, you'll learn later when you work with these a lot, that automatically is a y equals x function rule. Okay, I hope that made sense to you. All right, so let's take a look at your worksheet. So it's going to be just like what we did in our notes. The top half is complete your function rule. Write your function rule right under here from what you see in your input-output table. So you're identifying your start value and your rate of change. Don't let these decimals mess you up. They're dealing with 1/2. All right, and then down here, same thing. You're going to be identifying your start value and your rate of change from the graph and completing your function rule here. All right. You may write an input-output table out here if that helps you identify it. And your teacher might require you to. Different teachers have different rules about this. Okay, so it's just like what we did in the notes, guys. So that leaves us with our exit ticket. Here it is. Exit ticket is extra practice. I don't show you how to do this or give you the answers. Your teacher may use this as assessment. All right, so that's lesson 4.6 out of the Introduction to Algebra book. Remember, the only way to learn math is to do math, and mistakes are proof that you're learning.